Hello. Any particular section of work that you'd like covered? Ria, since you are here, seems like you are here alone. Or at least I think there's three of you. Is there anything that you would like to actually have covered? What grade are you in, by the way? Ria Mokhetselebi. Nice ring. Nice name. Ria Mokhetselebi. So nice. So nice that you can join in. Oh, you got 50 out of 50 for the assignment. Oh, wow. Oh, yeah. Oh, wow. Grade 9. That's amazing. Good job. If I was on TikTok, I would be clapping for you right now. We'd do the whole applause. That's amazing. Wow. Well done. That is excellent. Wow. Wowza. Okay, you're in grade 9. So is there anything in term 1 that you particularly had, you feel like you'd like to have a run through again? Or would you like me to jump into some term 2 stuff? Hello, Nchepe Rahodo. How are you doing, Nchepe? Is it Nchepe? Nchepe from where and what grade are you in, Nchepe? Or is it Nchepe? Hope I'm saying it right. So we got Ria there. You got 50 out of 50 for the assignment. This is so sweet. First time present orally, first time present on live session. I usually watch the videos a day or two after uploaded. Epic. Orally, what grade are you in? Let me know. Just let me in on the comment section. Just let me know which grade you all are in. And maybe you can let me know if the videos have been helpful by any chance. So Nchepe Rakhot as well from Pretoria North, grade 9. Okay, epic. Okay, so I'm wondering if there's anything in particular that you guys would like me covering. Okay, I love that you all are in grade 9, or at least most of you are. Orally is in grade 11. Maybe we can split it between the two of y'all. Maybe we can split it between the two grades. We can have a bit of grade 9, grade 11, grade 9, grade 11. We can develop like 5 minutes to grade 9, 5 minutes to grade 11, 5 minutes to grade 9, 5 minutes to grade 11. Maybe the first person who comments on the comment section what it is they'd like done, then I can actually check on that. Geometry of straight lines. Okay. It's like grade 9, geometry of straight lines. Okay, let's cover a little bit of that together. Geometry of straight lines. This will also be helpful for a grade 11 learner. Obviously, grade 11s in term 2, you guys will start doing geometry as well. Okay, but since Ramokha says geometry of straight lines, let's jump right into it. Guys, I love geometry. Ramokha, how do you feel about geometry? I love geometry. Geometry is it's become one of my favorites of all time. Okay. Just before we jump into it, let's cover some theory, okay? Let's look at some theory, okay? So lines and angles. Let's look at some geometry. I failed it, okay? Let's see if we can't get some tricks up and rolling for you, so that you can start enjoying it a little bit more. Okay, so this will be good recap for a grade 11 learner. Geometry of straight lines. Okay, so first and foremost, let's look at what this is. So this is what we refer to as a line segment. Okay, all right, and then this line segment, let's say it is touching another line segment. Where these two line segments they meet, we call this a vertex. Okay, and then basically there's a space in between one line and the other, and we can measure it in degrees. We call this an angle. All right, this is very important to note. So we call that a vertex where two lines join or meet together. We call that a vertex, and then the space between, measured in degrees from this line to that line, we call that an angle. Okay, so this we refer to an arm, and this would also be referred to as an arm. Okay, then listen up, and this is sort of really important, that if let's say we label this line segment as AB and this line segment as BC, if we are speaking about this particular angle, there's a few ways in which we can name that particular angle. This angle here is referred to angle ABC. We put a cap on the B as the middle letter to show that that is the angle that we're referring to. So if you look at the arm, move from arm AB, from B to C. So we say AB, the middle letter, referring to the angle C. And then we put a cap on top of the B to indicate that that is the angle we are referring to. That's one way of naming an angle. Or we can say angle ABC. So same letter, but different notation. We put this symbol, which also stands for angle. And remember, the middle letter is the angle we are referring to. It can never be the letter A or the letter C. Okay? Or we can change around the letters, swap C and A around, and we say, okay, I'm sorry about that, guys. I don't know what happened there. For a moment there was a problem. But that there was, because there was an error that was made by me here. I was supposed to say this angle is angle CBA, or we can refer to it as angle CBA. Alright, as long as we have the middle letter that's referring to the angle, that is basically the angle. No, I wasn't clear because there was a bit of interruption there. Okay, I don't know if the network is still giving you guys problems, but for a moment there there was a problem with the reconnection. Okay, we can't see. So you can't see still. It's kind of blurry. I'm very sorry about that, guys, that we couldn't see there. Okay, so like I was saying, this is angle ABC, that's angle CBA, alright? Or sometimes they just simply say angle B, alright? But that's the thing, if we have angle B, and I mean, there's another angle on this side. Guys, I'm sorry. My network is really bad. It's really bad. Network is really, really bad. It's not serving me well. Okay, but anyways, I'm going to continue. I am going to continue. Okay, despite the bad network. Okay. So let's look at the first relationship between angles that we do have. So let's say we have ADB as a line segment. And let's say we have ADB, and let's say that's line CD. Line AD and line CD. Then we have small letter x and small letter y. This angle represents the space between this line segment DB and CD, and then there's an angle from this line segment to this one. So So these are two angles. They are next to each other. We say that x and y are adjacent each other. The word adjacent means next to. Next to. Okay. So if we look at angle x and angle y, we say x plus y is equal to 180 degrees. All right. This angle x and this angle y together. So from the straight line to this line, and then from this line back to this straight line, we have two angles next to each other and they are lying on the straight line. So we say x plus y is equal to 180 degrees. Y angles on a for straight line. That is the reason. So there's a theorem in Euclidean geometry for your straight lines that says two angles added together that lie on the straight line add up to 180 degrees. Okay, so you are saying 90 plus 90 is equal to 180. Yes, 90 degrees plus 90 degrees is equal to 180. But remember that this particular theorem is saying that if you have two angles next to each other and they lie on a straight line, then it means that these two angles, if you add them together, should give you 180 degrees. And the reason that we use whenever we are using this particular deduction is we say angles, this symbol for angles on a STR dot line, angles on a straight line. Okay, that's the first theorem. Two. We have a line segment, let's say it's CD as well, and then we have A and B. Okay. Here we go. Now this here, we say that CD is perpendicular. CD is perpendicular to AB. CD is perpendicular to AB. So in other words, what we're saying here is that, all right, if let's say this is X and this is Y, if we know that angle Y, which means from here to there, is 90 degrees, then it also stands to reason that X is equal to Y, which is equal to 90 degrees. Why do we say so? Because CD is perpendicular to AB. Okay? Yeah. So that's something very important, that the angle X and the angle Y, so this angle plus that angle, obviously they lie on the straight line. If that is 90 degrees, this box indicates that CD is perpendicular to AB. Therefore, the angle X as well is equal to 90 degrees. So X is equal to Y, which is equal to 90 degrees. That's something we can conclude. Why? Based on the fact that CD is perpendicular to AB. Okay. Let's look at 3. If we have two straight lines that intersect, in other words, they cut across each other at a specific point, these two lines, they form, or let's say in these lines there, let's say there's angles. Angle A from here to there, angle D from here there to here, angle C from there to there, and then angle B from there all the way back to there. So what we can say is that you can see at the top here there's A and the C. So we say A is equal to C. The angle here, which is directly opposite the angle C, and this angle is equal to that angle. Letter angle A is equal to letter angle C. Reason, we say they are vertically opposite. So we say vert op angles. So vertically opposite angles, right? But vertically opposite angles are only formed when there are two straight lines that intersect with each other. Very important. These two straight lines must cut across each other in order to form angles that are opposite each other, which we refer to as vertically opposite angles. What is their relationship? These angles are equal. So A is equal to C. In the same way, D and B are vertically opposite. So we say D is equal to B. And the reason is vert op angles. Okay? So the relationship that exists between A and C is that these two angles are equal. What's the reason? They are vertically opposite. D and B are also equal. Reason? They are vertically opposite angles. So for short, we say vert dot op dot angles to indicate the reason why we say A is equal to C. Interestingly enough, A and B, on the other hand, they lie on this straight line. So what relationship exists between A and B? We would say A plus B is equal to 180 degrees. And the reason is angles on a straight line. What about D and A? They are also angles that lie on which straight line? This straight line. So we'd say A plus D is equal to 180 degrees. What about D and C? We would also say D plus C is equal to 180 degrees. And then what about C and B next to each other? These angles also lie on a straight line. We'd say C plus B is equal to 180 degrees. Very, very important, that deduction. Number 4. Now this is very interesting and I want you to take note of this. Now, this here is a straight line, but this one is not. This line from here to there bends and this one connects to there, all right, is not a straight line. So something to note is that, you remember here we'd say A and C are equal because they are vertically opposite angles. The reality is this B and this D are not vertically opposite angles. Why? Because they are not formed by an intersection of two straight lines. So we don't say B and D are vertically opposite and they are equal. Not at all. B and D are not vertically opposite angles. So we would never say B is equal to D. Hello, Nchepo. Hello, Nchepo. So B and D, they are not equal. Just like A and C are not equal. Why? Because they are not formed by two straight lines intersecting each other. So this vertically opposite angles, the angles A and C being equal, and then D and B also being equal, have to do with the fact that these two straight lines need to intersect, and they need to be lines that are straight. These two lines, from here to there to here to here, this is not a straight line. And then this here is a straight line. So B and D don't have a vertically opposite angle relationship. We don't say B is equal to D. We don't say A is equal to C. And that's very important to note. But here, from here to there, there's an angle. From here to there, there's an angle. From here to there, there's an angle. And then from there to here is an angle. So very importantly here, we say A plus B plus C plus D. All of these angles, they add up to what? Now I want to check if there's anyone in the comment section who will actually let me know. This A plus B plus C plus D is equal to what, guys? Anyone in the comment section who knows what A plus B plus C plus D is equal to? And the reason why we say it is equal to whatever I'm about to say or someone is about to type in the comment section? These 1, 2, 3, 4 angles. Whoa, orally, very good. Ramokhetsa, you said 180 and 360, but very importantly, guys, these angles, A plus B plus C plus D, they complete a full revolution. A revolution is what? It's when we are actually able to move from one point, move away from it in a circular motion back to that point. We call that a revolution. Okay? And a revolution is 360 degrees. And the reason we say that, it's because we can say our reason is angles around a point. Okay, angles around a point, we can say. Or we can say angles in a rev. Okay, both of these reasons are acceptable. So as a grade 9 learner, it's very important to use these acceptable reasons, because in grade 11 and 12 and in grade 10, we insist on learners using the acceptable reasons to then back up why they have stated something. So guys, what I've written down here when I was saying x plus y on a straight line, when these two angles both complete a straight line from here to there, and then from there all the way back to the straight line, those two angles add up to 180 degrees. We say x plus y is equal to 180 degrees. This reason, angles on a STR dot line, this is an acceptable reason used in the exam guideline. Okay, check is about reflection of line. Oh, okay. Then here, when two lines are perpendicular and y is 90 degrees, we say x is also equal to y, which is equal to 90 degrees. The reason is CD is perpendicular to AB. The fact that we say when two straight lines intersect, then they form opposite angles, which we refer to as vertically opposite angles. Those angles are equal. A is equal to C, just like in the same way, very equal as well is the fact that B is equal to D. A is equal to C, vert op angles, and I'm using the acceptable reasoning that is used in the exam guideline. So vert op angles. So it's good to be familiar with these ways of writing these shorthand reasons. Then here, angle, this A plus B plus C plus D being equal to 360 degrees, that is angles around a point, or we can say angles in a rev. In other words, angles in a revolution. Right? So these are the fundamental basics that we learn for lines and angles. The geometry of lines and angles has to do with us being able to state when angles are on a straight line, they add up to 180 degrees. In other words, angles on a straight line are supplementary. That's another word we use, supplementary. If lines are perpendicular, then it stands to reason that the angles formed on either side of the line, they are equal to 90, both of those angles. Vertically opposite angles are equal. They are formed with two straight lines intersecting. Then angles around a point add up to 360 degrees. Very important. So guys, all of these are so very important. So that is the basics that we learn when we are doing lines and angles. All right. Now, I'm going to move on to parallel lines. For parallel lines, we speak about three relationships that exist. Angles formed between parallel lines give rise to three fundamental relationships. So I'm going to speak about the first relationship here, a relationship that we refer to as alternate angles. Now, if lines are parallel, very important that there's a condition here, that if lines are parallel, then the angles formed here and there, we call them the Z shape. Very important, this Z shape. There's the Z shape that is proper, there's the Z shape that is improper. The angles formed here and there, those two angles, we say that they are equal. But that's only on the basis if the lines are parallel. Then those angles here formed, we say those angles are equal. All right. So let's say that was A and that was B. We would say A is equal to B, and we would say the reason is alt angles for short. I'm going to just rewrite that. A is equal to B, alt angles. Okay. And then after saying alt angles, we then have to mention the lines that are parallel. So in this case, we will say AB is parallel to CD. All right. So we would say A is equal to B. All right. You can see most the Z. Okay, that angle formed with our Z at the top. This angle formed here is equal to this angle formed there. We call it alternate angles. And we state the lines that are parallel whenever we mention alternate angles in short form. Also, let's say we had C on this side and we had D on this side. There's a Z shape on this side as well. The funny Z, this angle and that angle, we call it the weird looking Z. So C is equal to D, and we say alt angles, stating the lines that are parallel as AB being parallel. Guys, these two lines are two lines that indicate parallel lines. Okay, they indicate parallel lines. I hope you guys are with me there. A is equal to B, alternate angles, AB is parallel to CD. C is equal to D, parallel lines, alternate angles. When your reason does not have this part, it becomes incorrect. You must state the lines that are parallel as well. Do not just be happy about writing alternate angles. And please guys, those who are in grade 8 and 9 must get into the habit of writing ALT which is alternate for short, the symbol for angles, which is also for short, and then stating the lines that are parallel. Okay, very important. That about ends us clarify what we mean by alternate angles. Is the Z shape are basically vertical. We say it's shape. Okay. I hope you are with me here. We say it's the Z shape if the lines are horizontal and they are parallel. But if the lines are parallel in a vertical direction, then we say that the N shape. Z shape for when they are horizontal, N shape when they are vertical, or when they are listed in any other direction. But N and Z, they complement each other. The second relationship that exists between parallel lines is the relationship of corresponding angles. Corresponding angles. I repeat, corresponding angles. What about corresponding angles? If lines, guys, are parallel, then we say that corresponding angles are also equal. What shape or letter can we associate corresponding angles? We say it is the F shape. The what? The F shape. And I usually say it is on top, on top, on top, on top, or it can be the bottom, bottom. And maybe you are asking yourself, what does this guy even mean by on top, and bottom, bottom? And I say on the same side of the transversal line. Transversal line. Transversal line. Sorry guys, now I need to speak about a few things. These lines, we call them parallel lines. Okay, just want to write another pair of parallel lines. These are parallel lines. But this line here, the one that cuts through the two parallel lines, we call this a transversal line. Transversal line. So we have the lines, let's just use different letters, EF, and then we have GH. Okay, we say these two lines, EF and GH, are parallel lines, guys. EF and GH are parallel lines that cuts through the parallel lines. We call the line a transversal line. Now, an angle formed on top of this side of the transversal line and on top of this side of the transversal line. We say that those two angles are equal. That's why I was saying it's on top, on the same side of the transversal line. So on the left side of the transversal line, on top, we say those two angles are equal. So if that was A and that was B, we would say A is equal to B, and we'd say the reason is angles, and then we'd state EF is parallel to GH. I repeat again. This angle is on top of this parallel line, and this angle is on top of this parallel line, formed by the transversal line and the parallel lines. On top angle, on top angles, on top. That means A is equal to B. We say these are corresponding angles, and we would write the reason as EF is parallel to GH. So corresponding angles is very important to state, but then we follow it up with stating the lines that are parallel. That was on top, on top. Now let's go on the other side of the transversal line. On top, on top. This angle on top, this angle on top. On top, on top. Let's say that is C and that is D. We would say that angle C is equal to that angle that is given by the letter D. And we give the reason. The reason is corresponding angles, and we'd state the lines that are parallel. EF is parallel to GH. On top, on top. So that's on top, on top. And you check the side of the transversal line that we were referring to for A is equal to B. It's on the left side of the transversal line. Then C is equal to D. On top, on top. But on the right side of the transversal line. Then we have bottom, bottom, guys, which you also need to check out because that's also referring to corresponding angles. Bottom, bottom. Now, on the bottom of this particular transversal line, there's an angle from here to there. This, we would say, bottom, bottom. Okay, bottom, bottom. Are we together? So therefore we would say, in other words, if there was a letter, let's say E and F, we'd say E is equal to F. Whatever that angle is at E is equal to that angle that is at F. That would therefore mean that those two angles are equal. We'd say corresponding angles. We'd state the lines that are parallel. EF is parallel to GH. Are you with me? Yeah, I hope we are together, those who are watching and watching very closely. E is equal to F. Bottom of this line on this side of the transversal line, bottom of this side of the transversal line, bottom. So E is equal to F, bottom, bottom. But that's not the only bottom, bottom that we have. Let's say we had this bottom and that bottom. Let's use a dot here and a dot there. Okay, and let's say EF, G, and H. Let's say this was angle G, that was angle H. What would we say? G is equal to H. What is the reason? Same reason. Corresponding angles. Then we state the lines that are parallel. EF is parallel to GH. All right. So I hope you guys see this. This is so beautiful. Now, something you should note is that there's a relationship even between these two angles. All right. That has nothing to do with parallel lines. It has to do with the fact that from what we've already learned, when we have two straight lines intersecting each other, this angle A and this angle G are vertically opposite each other. And already you can see that there's a dot and a dot for both. So that means A is equal to G. The reason it would be vert-op angles. E is equal to C. That would also be because of vert-op angles. There's a relationship between this X and this dot, this angle formed by the X and this angle formed by the dot, because they are both angles next to each other and they lie on a straight line. So we'd say C plus G is equal to 180 degrees. And when we state the reason, we'd say angles on a straight line. Right? So these relationships, guys, as long as we are aware of the relationships that exist between angles, we should always be able to go amazingly right. No issues, no problems, no challenges. Okay, so that is enough about the F-shape corresponding angles. And then last but not beautifully least, we have the last relationship that is there between parallel lines. We refer to that relationship as the U shape. Okay, I usually call it the U or the C shape. Just depends. Just depends. Okay, so if we have the transversal line again, we have this angle. This video will automatically save itself after I'm done, when I've ended the live. So you can always come and check it out. You're just going to have to go to my live tab on my videos. My live tab, it will be uploaded onto my live tab. I'll try and rename the video, and I will rename it as Geometry of Straight Lines for grade 8s and 9s, so that you can actually locate it. Okay, so the U shape, there it is. There it is. So it's the C. You see what? That's why I said it's C if it's horizontal, but if it's vertical, it's the U shape. At the end of the day, U or C shape, the angles that lie in between the two straight lines, all right, on the same side of the transversal line, we call these co-interior angles. So co-interior angles that lie in between two parallel lines, inside. So interior means inside, and you can see this angle is inside, this X is also inside. So this angle and this angle, they are not equal. Sorry, these two angles, A and B, we say A plus B is equal to 180 degrees. Co-interior angles are not equal, they are supplementary. What does the word supplementary means? It means they add up to 180 degrees. Thank you guys for the likes, really appreciate it. This angle A plus that angle B, when you add them together, they equal to 180 degrees. So we would say co-int angles, and then if their lines that are parallel have been stated, then we'd say AB is parallel to CD. Okay, very important. A plus B is equal to 180 degrees. I must watch it relaxing. Okay, that's fine. Doesn't matter, that's fine. I have no problem with that, guys. Yeah, I'm really sorry that it is not as clear as I guess we would all want it to be. Yeah, I don't know why that is the case, but I guess it just is sometimes. Yeah, I'm very sorry about that. Okay, very, very sorry. Okay, so yes, very important. Okay, yes, it's recording itself. It's recording on its own, so it will definitely save the video, and then it will upload on its own, like I said. So don't worry about that. So like I said, these are angles that are, we refer to them as co-interior angles. Okay, I don't know, I think this light is also doing the most too much. So A plus B is equal to 180 degrees co-interior angles, because we said, like I said, it's AB is parallel to CD. We give the straight line, the parallel lines, we must state the parallel lines after stating the angles that are co-interior. So this is all I guess the basics that are contained for angles that are between lines. Okay, now we are going to look at some problems. We've looked at the theory, right? At least the theory as it relates to lines. Okay, I haven't looked at triangles, but I think let me hold the triangle theory for later. Okay, I will do the triangle theory again, maybe in another live, but let us go and check out the following very quickly so that we can, yeah. So when we are told calculate giving reasons, the value of x, calculate giving reasons, the value of x. So let's, for a moment, let's look at this problem. So they want us to find the value of x giving reasons. Okay. So how would we go about answering this question? So I'm sure you guys can see this is BD, this is BC. This box means perpendicular, and this angle here is 90 degrees. From here to there is 90 degrees. We know that. So I can actually say ABC is equal to 90 degrees. And that is actually given to me. Okay, that's given. In other words, AB is perpendicular. You can see to what? To BD. That's given. We have that as knowledge for us. Now, x and 20 degrees are actually part of the 90 degrees. X is the angle from here to there. 20 is the angle from here all the way to there. Together as a sum, they give you 90 degrees. So we would say x plus 20 degrees is equal to 90 degrees. And I love what orally said. Orally said the reason would be comp angles. And we use comp to mean complementary. All right, complementary angles. Complementary angles are angles that add up to 90. 90 what? 90 degrees. Complementary angles. So if we say x plus 20 degrees is equal to 90 degrees, that is because these two angles actually add up to 90 degrees. Then what do we do after that? We solve for x. 20 gets transposed to the right hand side. When that happens, 20 changes to negative 20 degrees. Then our value for x is equal to what? 70 degrees. Done, and that's it. Okay, finished. So this would be very important. AB is equal to 90. Reason is that new statement, x plus 20 degrees is equal to 90 degrees. Reason, complementary angles. Then we solve. X is equal to 70 degrees. You see? So this is not too shabby at all. Okay, angle AB. Did I say C? Can't say ABC. ABD. Okay, you see these errors that I made here? Angle ABD. The entire angle from here to there is 90 degrees. Very important. Okay, ABD is equal to 90 degrees. That's given. Then I'd say x plus 20 degrees. That x plus the 20 will give me the 90 degrees. What's the reason? Complementary angles. Then I solve for x. Transpose the 20 degrees. When the 20 crosses over to the right hand side, it changes sign from positive 20 to negative 20 degrees. Then I get an answer of x is equal to 70 degrees. So I'm hoping as you are also were looking at the problem and as you were seeking to do it, you were able to see how x can easily become 70 degrees. And all of our steps, the statement, the reason, the statement, the reason, these are important because our reason need to accompany the new statements that we state. Okay, let's go to number 2. Here's another one for you. How would we start this one off? What would we say here? My grade 9s, amazing grade 8s, 9s. In fact, I mean, this would be good for anyone. Okay, what can we do here? What can we say here? We obviously want the value of x. This is x. There's an angle from here to there, that is 35 degrees. And then there's an angle from here to there, that is x. Now we need to find the value of x. So what can we say here, guys? Anyone have any ideas? Any bright ideas? Oh yeah, orally, you high. Orally is like amazing. They're doing the most. What would be the reason? Because that's important. So the statement orally as stated in the comment section is amazing. X plus 35 degrees is equal to 180 degrees. What is the reason? Because that would be important to make sure that we solidify the amount of marks that we want to get for this particular question. So yes, we'd say x plus 35 degrees. That's the grand statement, is equal to 180 degrees. What is the reason? Because that reason is very important. And remember, like I said, we need to write that reason in the symbolic form that it appears in our exam guideline. So yes, angles on a, we write str dot line. Okay, guys, there's no reason why the person who's marking you shouldn't give you the statement mark and the reason mark. Okay, then the next few marks you get because you solve for x. Now solving a linear equation shouldn't be a problem. So the next grand thing is the hard work has been done. Now all the easy work is left for us to do. We transpose the 35 degrees. We write it on the other side as negative 35 degrees. Then x is equal to what's 180 degrees minus 35 degrees. Let's see if your maths brains are on and if your mindset calculators are also on. Let's see if someone can actually give me the answer there in the comment section. It seems like orally is the only one that's really on the money here. In the comment section, they're commenting, giving equal time there. 180 degrees minus 35 degrees is equal to that's because I'm in grade 11. You're killing me. That's why. Okay, at least you came out from the crevices and you exposed yourself. Hopefully term 1 went well for you orally. The grade 11 mathematics term 1, it went well, I'm hoping. Yes guys, it's 145 degrees. That is essentially the answer. So that will basically then lead to our last and final mark. But it's always nice orally for those who will be doing Euclidean geometry in this coming term 2 for grade 11. It's always nice to be good at these basics because these basics actually form an integral part of your Euclidean geometry for grade 11. They are still relevant and very much important. So you need to make sure these basics for lines and angles are also good. Nah, man. Seems like orally is still hung up. Yeah. So basically, you have not taken control over your maths destiny. You still it's still hung up on the province and the state and the district and the national papers and so forth. You need to take ownership, eh? The sooner you do that, the better, alright. Trust me. Okay. The sooner you do that, but I know that Free State usually does very well. And remember that the papers that you guys get set for in that province are supposed to equip you so that you are able to be in a better position to face the papers, in the next grade. So don't be despondent, don't be disheartened. Rather take heart and actually utilize the papers after having written them to actually check where your fundamental conceptual gaps are, so that you can make sure that those are covered for the next term. Because remember, you guys in June, you're going to be writing 4 papers, paper 1 and paper 2. So you need to make sure that you are full on prepared for those. A full paper 1, and full paper 2, at least for the June period. Okay, so whatever topics are covered in term 2 will obviously fill up on that paper 2. So that you can have I think 100 marks for paper 1 and 100 marks for June paper 2. Okay, so yeah, one needs to be prepared for that. So anyways, here we have x, here we have 60 degrees. Now we want to calculate the value of x. These are 2 straight lines, they are intersecting each other. What's the relationship between the x and the 60 degrees? Okay, seeing as though that these 2 lines, they are intersecting each other and they are straight lines. No, I won't abandon you orally, not at all. Oh, you love me. I am touched. Thank you. Love you too. So x is equal to 60 degrees. Not gonna abandon you. So x is equal to 60 degrees. What's the reason? Vert op angles. There it is. So this x is also 60 because these are vertically opposite angles. When the angles have a vertically opposite angle relationship, we say that those angles are equal. Right? So there it is. Tick tick. Okay, moving right along. Let's look at this question. What about this one? What are your thoughts? Yes, nice. You've been listening very well already. Okay, I get the fact that you're in grade 11, which is good, but like I say, you've been listening very well. Okay, so we say x plus 50 plus 140 plus 90. X plus 140 plus 90 plus 50. So you can see that this completes a full circle or a revolution, equal to 360 degrees. Okay. 360 minus 50 minus 140 minus 90. Okay, so I transposed every single term. Obviously left the x on the left hand side because it has to be the subject of the equation. 360 minus 50. So we have 280 basically. 280, 360 minus 280. That gives us okay, let me wait for someone to actually comment in the comment section rather than take all the glory. I'm sure someone is going to type in somewhere. So I love the fact that you said angles around a point orally. That's one reason you could have written there, or you could have written angles in a ref. Okay, both are acceptable, those are fine, very well and fine. So 360 minus 50 minus 140 minus 90 degrees, that will give us a beautiful, amazing what exactly? Nice already. Nice. 80 degrees. Okay, there it is. Statement, reason, 1, and then the value of x. Okay. Okay, let's do another one. What about this one? Okay, there it is a little bit better. The value of x. What relationship exists there? How would we, what would be the statement, what would be the reason, and then what would be the answer? Nice. Very good already. Very good. So angles on a straight line, of course. So we'd say x plus 180, 28 degrees is equal to 180. Reason, angles on a straight line. Okay. So then x is equal to 180 degrees minus 128 degrees. So our x value there would be what? What's 180 minus 128? That gives us a beautiful 52 degrees. So once again, statement, reason, answer. Statement, reason, answer. Then, moving right ahead, like we are not even friends. 145 degrees, we've got an x there. Relationship that exists between these angles, x and 145 degrees, we have two straight lines that are intersecting each other. Alright, so if the two straight lines are intersecting each other, what relationship exists between those two straight lines? and what angles basically exist between 145. What do we call the angles? The relationship that exists. Yeah, all of these things are relationships. There's a relationship between the 145 and the x. And what is that relationship? So therefore, what is the value of x with its accompanying reason? Yeah, x is equal to 145 degrees. We state the reason, vet, op, angles. Okay, very important. Okay, moving right along, steam ahead. Okay. Okay, what about these ones? I have this one. There's a box with X's inside, and then this one is like two lines that are intersecting. You have X, you have X, you have X, you have X, and we need the values of X. So let's start with this one and then go on to that one. All right, maybe you can do those, guys, and let me know what you think on the comment section with this first one, and then also the second one. Statement and the relevant reason, and then the solution. Statement, reason, 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 solve for the 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 solution. I think that's kind of like how it goes, eh? Statement, reason, solve for the solution. 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 90 divided by 2 is equal to x, which is equal to 45. Okay, nice. I like that. I like that first one. Complementary angles. Okay, I love that. That resonates with what I would have said. X plus x is equal to 90 degrees. Comp angles. 2x is equal to 90 degrees. We divide both sides by 2, so x is equal to 45 degrees. So orally, maybe it's just slight differences in approach, but basically fundamentally it's the same thing that we have both stated. Okay, then for this one, thank you so much, orally. You are so amazing. I think I'm beginning to really not only love you, but like you as well, because you are really this is what is it, John 14 verse 15, if you love me, keep my commandments. And basically, in essence, not saying that I'm Jesus or anything, but I'm just saying in essence that you are showing a lot of love in that you are actually helping make the live session a bit more lively by commenting in the comment section and just participating. So thank you. There we have the X's, 4 of them, intersecting lines. Nice. 30 divided by 4 is equal to x is equal to 90 degrees. Okay, nice. Thank you so much. So yes, once again, I would say x plus x plus x is equal to 360 degrees. Statement, reason, angles. I guess I just love angles in a rev. Okay, but angles around the point would also work. Angles in a rev. Then we go ahead. 4x is equal to 360 degrees. Divide both sides by 4. We get x is equal to 90 degrees. Alright? Yeah. Okay, angles in a rev, very true. So this x plus this x plus this x plus this x are all angles around, okay, this point. Very importantly, so if you add those angles together, they give you 360 degrees. The reason is angles around a point or angles in a rev. Then we add these angles equated to 360. Then we divide by 4 the coefficient of x, both sides. When we are solving for a linear equation, we get x is equal to 90 for this particular one. Statement, reason, answer the solution. Statement, reason, solve the solution. Statement, reason, solve the solution. Well, that's the reason, sorry. Marking the wrong place there. Okay. This is looking so sweet. Okay. Let's go. I think we're entering into the world of parallel lines. Parallel lines. Okay. Let's solve for x there. Okay. Statement, reason. Relationships that exist between parallel lines. What's happening there between that x and that 40? Is there even a relationship? If there is, what is it? And can a statement then be given that is a statement that supports the diagrammatic representation? Okay, so what's always nice is to kind of go back to the notes, because in our notes we basically looked at the relationship between parallel lines. We did state that there's the U-shaped relationship, which we refer to as co-interior angles. Co-interior angles are supplementary. Those are like your armpit angles. If you look at your armpits, like your makwapa, your armpits, those are basically armpit angles. If you stretch your arms forward in front of you, then you have your armpits, your armpit angles, your co-interior angles. They are supplementary. All right. Then we have our alternate angles. Alternate angles, if lines are parallel, the alternate angles, remember the angles, where is the location of the angles? This side, this side. This side, the other side, they are alternate angles. This side, the other side, they are alternate angles. The Z shape or the N shape angles. Then you have the corresponding angles. Yes, be very careful there orally, not complementary as you had made a mistake in the beginning, but corresponding angles. F shape on top, on one side of the transversal line, or bottom on one side of the transversal line. Okay, top, bottom. Very important. Top, they are equal. Bottom, they are equal on one side of the transversal line. So as rightfully said there orally, as you had corrected yourself, x is equal to 40 degrees on top, on one side of the transversal line. So that is really our F shape. Look at it. It's the F shape. It really truly is the F shape. On top. X equal to 40 degrees. Reason? Angles. Then let me just enforce that they be parallel lines. If there were no parallel lines, you would just write the symbol of parallel lines to just indicate that you've acknowledged that these are corresponding angles because lines are parallel. But of course now we've added AB is parallel to CD. Okay. Okay, let's look at another one. Let's look at another one. There the lines are, there the lines are. We have 67, we have x. The lines are parallel. What do you think? What is the value of x? And the reason? What relationship exists? The relationship between 67 degrees and x? What is their relationship? Relationship between x and 67 degrees is, drum roll, drum roll, drum roll. Okay, good job orally. Hopefully orally, as you write down alternate angles, you're not forgetting the fact that we need to make sure that in order for our reason to be full, we need to state the parallel lines. So in this situation, xy is parallel to ZA. Very important. So we don't just write alt angles, but we state the lines that are parallel. If we do that, we'll have fun in the sun. If we don't do it, we're gonna cry alone. Okay? Yes. Statement, reason, state the solution. Statement, reason, state the solution. Man, I keep on grabbing all this white paper here. Okay. Orally, are we still good? Aren't you fatigued yet? Here's another one. X. The relationship that exists here. And what is the bendifuna ukuyenza ama-function reclaring mar. Oh, you want to do functions? Okay. Maybe then I'll conclude this then. And then I'll do functions for you, Shaman. Okay, so the x value here. Yes, very good. X plus 55 degrees is equal to 180, yes. Coint angles. We state the lines that are parallel. MN is parallel to OP. Very good. Orally, very good, very good. Then we can solve for x. X is equal to 180 degrees minus 180 minus 55 degrees, which gives you 125. Okay, I think you guys get the point. I think you get the point. All right, orally, I think I'll hold it right there for our straight lines, and then I'll pick it up again next time. Uh, for those that basically wanted me to, I think what I'll do now is I'll end this live. I'll start another one, and maybe you can join me back up so that we can continue then with functions. What do you think? Okay, let me end this live then. Thank you so much, guys, for those who joined in, especially my grade 9s that were here. I don't know if these guys are still here. Unchepe, Remokhetse, Nati, and company. But I guess if not, then I guess that's fine. What I'll do now is I'll end this live so that we can save this recording for the purpose of making sure that the geometry for the grade 8s and 9s, at least the foundation, is fine. I think this can also be relevant for the grade 10s, the grade 11s. It's sort of like a foundational work for the work that they ought to do as they basically enter into the realm of the work that is in grade 11. But yeah, guys, I think let's end it here. Thank you so much. I'll come back up again. I just want to end this live. I'll come back up so that we can do functions.